Geometry. Let's finish up with geometry for grade 11. No, it's not going to be the end of it. You're going to still have to do some riders throughout the year. Because if I leave you here and next year, June, you've got to write about this, you're never going to know what's going on. You need to practice everything, but especially geometry, because it's a technique. You've got to know, you've got your 9 theorems to go look after, and that's the way that you can solve your riders, your problems. Now, this question says, prove that AOBC is a cyclic quad. What's the tools?
Converse.
How many? Three of them. Can only be a cyclic quad if the opposite angles, theorem 5 and 6, opposite angles are supplementary or the exterior angles equal to the opposite interior one. But what's the other one?
Both sides.
Both sides. Okay. So if I ask you to prove it's a cyclic quadrilateral, you've got to know these are the 3 things. Only those 3. So check out the sun. Now the sun has got a circle, but then you put up your hand and say it's impossible. A, O, B, and C is not even inside a circle. What's Name's problem? You hear me saying this a few times. You cannot think that way. You've got to prove that there would have, should have, could have been a circle. How? By proving one of those things. Now what have I got?
90 degrees.
What 90 degree? Why? What's 90? A2, let's call it A2, is 90. Why? Theorem 1. Line from the center of the circle. No marks for you. Bisecting a chord will be perpendicular. Do you see what I mean about that theorem? The angle A2 is 90 because of line from the center. Not perpendicular. To the center of the chord. I don't think I've written it that way yet. Or that bisects a chord. Is that okay? Using other words? But I'm saying that it's bisecting the chord. We're used to writing bisecting a chord will be perpendicular. So this is what happens with that theorem. Now what does that help me? What else?
You can get A right.
Okay, well that's also 90. But they did tell me that BC was a tangent.
Tangent.
Make a highlight. Make sure that you read what they give you. What does that help me? That it's a tangent. Isn't it the party hat? Why not? Because that child is dead. Tangent? Not tangent. Inside the head.
Okay.
Are you with me? But what other theorem have I got? Tan chord. No, it's not tan chord this time. Yeah? Radius and tangent are perpendicular to each other. So B, let's call it OBC, is also 90 because of radius perpendicular to tangent. And if you want to say tangent perpendicular to radius, that's true. What do I see? Because I'm trying to find that this AOBC is a cyclic quad. So I see opposite angles are supplementary. Please don't say equal. They are equal in this case, but that's not why it's a cyclic quad. It's because they add up to 180. The opposite angles are 180. So I've got A2 plus OBC, that gives me. So I'm telling them, do you see this? And my reason? There's no reason. There's no reason for saying that they add up to 180. Because they're both 90s, they will add up to 180. But then I'll say AOBC is a cyclic quad. And the reason there is converse of opposite angles of a cyclic quad. So that means if I can get them supplementary, it will be a cyclic quad. How many marks?
3.
Okay. Each of those have a good reason and a grade 11 reason. That's why normally you'll have 2 marks. And then converse, not for this, because this is what I was asking. Right, another one. So we're guessing that this time it should be, which reason?
Both sides.
The bow tie, because it stands out. But please remember there's going to be lots of other sketches as well. Much more complicated than this. We need to practice much more of this. So if they tell me that I have to go prove that A, B, C, and D are concyclic points. I could have just as well asked, is A, B, C, D a cyclic quad? It's not even a quad. It's not even been sketched. A, B, C, D hasn't even been sketched as a quad. Do you see it?
Yes.
It hasn't even been sketched. You don't sketch it in. The only construction lines you make is in the theorem proofs, the 4 that you should know of by heart by now. So now, if I have got to prove that this is a bow tie, then I need to prove that either A and B are equal for a reason. But you can't start there and say they're equal because it's a bow tie and that's why it's cyclic. You with me? There's got to be a reason why those angles are the same. So you're going to start somewhere, and man taught you, if you don't have angles, call them X, or call them A, or call them pit, or something. So if I start somewhere, and remember now this is also a tangent, so please take your red or whatever highlighter and make sure you can see it. So what tends to come to your mind if you hear tangent? Theorem 9, it's tan chord. It didn't there work, 1 in a million, but it does work here. So P1 would be equal to?
A.
Do you agree?
Yes.
So let's call P1 X, but then say it. Let P1 be equal to X, because if it is, then P1 will be equal to A for the reason tan chord theorem. So I'm on my way, hoping me proving that this is also X. Because if this one is X and that one is X, then I'm done. Then it's a cyclic quad because I can see the bow tie. So that's not worth a mark, but you're telling them what you're doing. Tan chord theorem. And then what?
P2 is equal to B.
P2 will be equal to B.
Oh.
Will it?
Yes.
Nope.
Wow.
There's no circle.
Oh.
But man, this is also not in a circle, yeah? But we're trying to prove a cyclic quad. Okay? Do you see it? You hear her mistake? Can't say that that's tan chord theorem, there's no circle. Once you know that it's a circle, then you can start saying it is. Alright, so what else? What else has been given? Parallel lines for no reason. There will be a reason why it's given. Which ones are alternate?
C and P2.
P2 and
C.
C. Okay, but what's P2's value?
That's the problem.
That's the problem. Okay, just check carefully. See if you see what I want you to see. Do you see what I want you to see?
Yes.
Corresponding angles. Do you see it now?
Yes.
Okay, X, also X. So B is also equal to P1. Reason? Corresponding angles. And you can't write that, you've got to write PQ is parallel to B, C. Then what do you see? I see that angle A is equal to angle B. Reason? Because they're the same. I don't write that here, they're both the same. Therefore, those sides, and please answer the question that they ask. If they ask, prove it is a cyclic quad, you say yes, it is a cyclic quad. If they say prove that the points are concyclic, then you say okay. A, B, C, and D are concyclic. Answer the way that they asked you. But the reason for it is what? Converse of bow tie. Bow tie. Angles in the same circle segment. And that's it for that sum. We've proven it. How many marks? Because this was difficult to see, although it's grade 9 work. And then again for your answer. So easily 5 marks inside of a question that's like 18 marks. Wow, 13 marks for a geometry sum can be. So each of those ones, subsections could be like 3 or 4 or 5 marks. Okay, practice makes perfect. Okay, proving that something is a cyclic quad again. I ask that anywhere inside of a question doing other stuff and then asking you to prove it, you've got to search for those 3 things. Now, where is A, B, C, D? Was it A, B, C, D? No, it was P, Q, or S, wasn't it? P, Q, or S. Question's wrong. Luckily I checked it beforehand. PQRS. Am I allowed to use color like this?
Yes.
Yeah, I'm not adding anything, I'm just highlighting to myself what I'm looking for. So which theorem do you think is a possibility there? Bow tie. Do you see the bow tie?
Yes.
Okay, what do you also see in this sketch?
Equals
The equals. What's that?
A, B equals to C.
Angles in the same? No.
Second segment.
Equal circle segments. Do you see the bow tie that's spread apart? So that would mean, and again I don't have any angle, so let's call that one, for instance, X. So on top of CD it's an X, so on top of AB should also be where? A Q. But we're going to say let, for instance, B1 equals B X, and then I'm going to say, therefore, angle Q1 will also be X because it's angles in this equal circle segment. Because of those lines being equal to each other. Now, if you're fearful and you want to first say because AB is equal to CD, that's fine, but you won't lose a mark for not saying it. Because that's why you'd say that it's equal circle segments. Now I'm done.
Wait, no,
Am I done?
no.
Yeah. Because they are equal to each other, I've got bow tie.
That's the sum.
So PQRS is a cyclic quad, or however way they asked it for me. Why is it a cyclic quad? Because I can see in that red quad, I can see bow tie working. Then there's no circle, there could have been one. So it's again the converse of bow tie. Angles in
Equal.
same circle segment. How many marks? Okay, they're not going to deduct marks for not saying that. You know the one is, so the other one would be equal to it. So you have to get them from this situation. Angles in equal circle segments. You see it, you're starting to look at it and you're seeing those equal little lines there. I'm glad about that. Alright, then I'm giving you homework. And the homework sum has got something similar to this. If I want you to go prove that that is a tangent, now we're off of the cyclic quads. Prove that it's a cyclic quad. How do you prove that it's a cyclic quad? You've got your three reasons. I'm asking you to prove that this thing is a tangent to circle ABC. Did I drink at break? Because there is no circle. Again, the same situation. If I want you to prove that that line would be a tangent to the circle going through A and B and C, I want you to realize how the technique is going to work. What's going to be the reasoning? It's tan-chord theorem. So tan-chord theorem would mean this angle here should be equal to B. If for some reason, magical reason, stuff has got to be given to me, if they are equal, then I will deduct that this is a tangent. So TP is a tangent because, this is not a whole reasoning, because of the converse of tan-chord theorem. So whenever there's a triangle, I'm trying to make you see something here, and I want to prove that that is a tangent to, and you can never draw the circle afterwards, not too bad, but it looks like an egg or something. If I wanted to prove that it was, you'd have to prove that that angle there was equal to this angle here, or
That angle thing,
because if it is, then it is the converse of tan-chord theorem. But looking for tan-chord, in your mind I want you to see somewhere there'll be a triangle, I'll have a line, I'm going to try and find those two equal to each other, or those two equal to each other. Then it would be a tangent to those 3 points, and those 3 points then would be called cyclic. Are you with me, guys? So it's all these backward sums that we also got to look at now. So that would be your next sum there by number F.